As you're watching this, a small machine the size of a car is drifting through the cold black void of interstellar space, more than 24 billion kilometers from Earth. It carries a golden record, a fading nuclear heart, and the silent whispers of a civilization that built it almost half a century ago. Its name is Voyager 1, and in about 300 years, it will reach the inner edge of the Oort cloud. In 40,000 years, it will pass within 1.6 light years of a dim red star called Gliese 445. But these are just the first heartbeats of its true journey. Tonight, we are not going to talk about decades or centuries or even millennia. Tonight, we are going to follow Voyager 1 across 1 billion years of cosmic time. We will watch suns being born and dying around it. We will see the Milky Way collide with Andromeda. We will witness the slow death of constellations you know by heart. And by the end, you will see the universe through the eyes of a probe that, in many ways, will outlive everything humanity has ever made. So sit back, because this is going to be one of the most incredible journeys you have ever taken. And it begins right now. To understand where Voyager 1 is going, we have to remember where it came from. In 1977, just a few months before its twin, Voyager 2, NASA launched this spacecraft from Cape Canaveral on a mission that was supposed to last only 5 years. Its goal was to fly past Jupiter and Saturn, send back a few stunning photographs, study their moons, and then quietly fall silent. But something extraordinary happened. The spacecraft kept working, year after year, decade after decade. It photographed the great red spot of Jupiter. It revealed the rings of Saturn in detail no one had ever seen. It showed us a tiny moon called Titan with a thick orange atmosphere that hinted at chemistry strangely similar to the early Earth. And then, after Saturn, instead of dying, Voyager 1 turned its instruments outward and started a new mission no one had originally planned: to leave the solar system, to become the first human-made object ever to enter interstellar space. That moment officially happened in August 2012, when Voyager crossed what scientists call the heliopause, the invisible bubble where the solar wind from our sun finally surrenders to the wind of other stars. From that day forward, Voyager 1 has technically been sailing in the space between stars. Today, in 2026, the probe is still transmitting, but barely. Its plutonium power source is fading. Each year, NASA shuts down another instrument to save energy. By the early 2030s, Voyager 1 will fall completely silent. Its radio voice will go dark forever, but its journey will not end, not even close. Because once the radio dies, the real adventure begins, a journey through silence, a journey that will outlast cities, languages, species, and even the planet that built it. Let's start with the first 1,000 years after Voyager goes silent. During this time, the probe will travel roughly 17 kilometers every second, the same speed it has now. That sounds fast, but on cosmic scales, it is barely a crawl. In 1,000 years, Voyager will move about half a light year from the Sun. It will be deep inside the Oort cloud, a vast spherical shell of icy bodies surrounding our solar system. To Voyager's instruments, if they were still alive, the Sun would now appear as just another bright star, not the dominant blazing center of the sky. The constellations would still be recognizable mostly. Orion would still raise his club. The Big Dipper would still scoop the northern sky. But astronomers on Earth, if humans still exist 1,000 years from now, would have a hard time tracking the probe. It would be utterly invisible to them, a dark, frozen body against an even darker background. Now let's leap forward. 40,000 years from now, Voyager 1 will have its first true close encounter with another star. That star is Gliese 445, currently sitting in the constellation Camelopardalis. Right now, Gliese 445 is more than 17 light-years away from us. But because that star is moving toward our solar system, and Voyager is moving roughly in its direction, the probe will eventually pass within 1.6 light-years of it. To put that in perspective, that is closer than any star is to our Sun today. If Voyager could still see, it would witness Gliese 445 swelling slowly into a brighter and brighter beacon over the millennia, then receding again into the darkness. It will be the first stellar flyby in human history, even if no human is alive to witness it. After Gliese 445, Voyager will continue toward the constellation Ophiuchus, drifting toward more distant suns. But here, an important truth becomes clear. Space, despite all the romantic images of stars packed close together, is overwhelmingly empty. The chance of Voyager actually hitting anything, even an asteroid or a comet in the Oort cloud, is essentially zero. It is a needle thrown across an ocean. Now let's accelerate again. 1 million years into the future. By this point, Voyager will have traveled about 50 light-years. That is a huge distance for a tiny probe, but still tiny on a galactic scale. Our Milky Way is more than 100,000 light-years across. So, in cosmic terms, Voyager has barely scratched the surface. But something interesting is happening to the sky around it. The constellations as we know them are dissolving. Stars are not fixed. Each one moves on its own trajectory through the galaxy. Over 1 million years, the familiar patterns of Earth's night sky, the patterns that ancient sailors used and that mythologies were built around, will be unrecognizable. Polaris will no longer be the North Star. Orion's belt will have stretched and twisted. The Big Dipper will be gone, replaced by an alien arrangement of stars no human has ever named. And Voyager, drifting silently through this changing sky, will begin to look like just another piece of cosmic debris among countless others. Around this time, something else important happens. Voyager will probably encounter a few microscopic dust particles. Most of them will be smaller than a grain of sand, but at the speeds involved in the galaxy, even tiny particles can do real damage. Over 1 million years, the spacecraft's polished gold-coated record may start to show pitting and scratches. Its outer aluminum surfaces will become slightly cratered. But here's the amazing part. Even with this slow erosion, the structure of Voyager will still be largely intact. There is no oxygen in deep space, so the metal cannot rust. There is no atmosphere, so there is no weathering. There are no oceans, no microbes, no chemical reactions. Voyager will survive in a way that nothing on Earth ever could. Now let's jump even further. 10 million years from now, Voyager will have traveled about 500 light-years from Earth. By now, our solar system has rotated significantly around the center of the Milky Way. Remember, our Sun takes about 230 million years to complete a single orbit around the galactic center. So, in 10 million years, the Sun has moved only a small fraction of that orbit, but Voyager, drifting on its own path, has slowly fallen out of pace with our Sun. The two are no longer traveling together in any meaningful sense. From Voyager's perspective, the Sun is just one of millions of yellow stars in a glittering sea. There is no special direction, no home, no origin point. Just stars. By this time, Anything biological on Earth that resembles us is almost certainly gone. Either humanity has evolved into something unrecognizable, or it has spread to other worlds, or it has gone extinct. Civilizations rise and fall over thousands of years. 10 million is an eternity, and yet Voyager keeps moving, quiet, cold, indifferent, a relic of a species that may no longer exist. Now we reach 100 million years. Time is doing strange things now. Continents on Earth are shifting. The Atlantic Ocean is widening or possibly closing again. Mountain ranges that exist today have eroded into flat plains. New mountain ranges have risen where there were once seas, and in deep space, Voyager has now traveled around 5,000 light years. It is roughly 5% of the way across the Milky Way. The probe might pass through a stellar nursery, a giant cloud of gas and dust where new stars are being born. It might drift past supernova remnants, the glowing wreckage of stars that exploded long ago. It might thread its way through tightly packed star clusters where suns are separated by mere light months instead of light years. And here is where something poetic happens. Voyager carries that golden record, the famous disk of greetings, music, and sounds from Earth. Bach, Beethoven, Chuck Berry, the laughter of children, whale songs, greetings in 55 languages. The record was designed to last 1 billion years in space. And in 100 million years, despite tiny dust impacts, despite slow cosmic ray bombardment, despite the immense passage of time, that record will still be readable. The grooves will still be there. The information will still be intact. The patterns of Bach's music, the voices of people who have been dust for tens of millions of years, still encoded, still preserved, a whisper from a vanished world, traveling toward stars that were not even born when those voices were recorded. Now let's push further, 250 million years from now. By this time, Earth's continents have rearranged into a new supercontinent. Some scientists have nicknamed it Pangaea Ultima, or Amasia. And the Sun has completed roughly one full orbit around the Milky Way since the dinosaurs first appeared. But Voyager is in another galaxy entirely, in a sense. Not literally, it is still in the Milky Way, but it has drifted so far that the relationship between it and our solar system is purely geometric, no longer historical. Voyager has now traveled thousands of light years. It might be spiraling around the galactic disk in a slightly different orbit than the Sun. It is no longer accompanied by anything familiar. 500 million years from now, things are getting truly cosmic. The probe could be tens of thousands of light years away, depending on how its trajectory has been bent by the gravity of other stars. And here's a fascinating idea. As Voyager passes near other stars over millions of years, even from far away, their gravity tugs on it ever so slightly. Each tug nudges it onto a slightly different path. Over hundreds of millions of years, those nudges add up. Voyager's trajectory becomes essentially random, twisting through the galaxy like a leaf in a slow river. It might fall toward the galactic center. It might be flung outward toward the galactic halo. It might even get ejected into intergalactic space, the unimaginable emptiness between galaxies. Now we reach the truly mind-bending part, 1 billion years from now. Let's pause and think about that number. 1 billion years is more than twice the time since complex animal life first appeared on Earth. It is longer than fish have existed, longer than reptiles have existed, longer than flowering plants have existed. By this point, our sun has changed. It has grown brighter and hotter, slowly but steadily. Earth's oceans, if they still exist, are likely boiling away. The biosphere as we know it is gone. Whatever life remains on Earth is microbial, clinging to the deepest oceans or hidden in subterranean rock. And in the sky, something extraordinary is happening. The Andromeda Galaxy, currently rushing toward us at about 110 kilometers per second, has been growing larger and larger over the eons. By around 4 billion years from now, the Milky Way and Andromeda will collide and merge into a single giant elliptical galaxy that astronomers have already nicknamed Milkomeda. But even before that full collision, 1 billion years from now, Andromeda is already noticeably closer. The night sky on Earth, if there is anyone left to look at it, would be dominated by a massive spiral hanging across the heavens. And Voyager has now traveled hundreds of thousands, possibly millions of light years, depending on how many gravitational kicks it has received. There is even a small but real chance that Voyager has been ejected entirely from the Milky Way and is now drifting in the vast intergalactic void. Imagine that. A small piece of 20th century human engineering slowly tumbling through emptiness so deep that the nearest galaxy is a faint smudge, millions of light years away. The Sun, the Earth, the entire civilization that built it, all reduced to a barely visible glimmer, if visible at all. But here is the most remarkable thing of all. The probe is still mostly intact. The golden record may have lost a microscopic fraction of its surface. The aluminum hull may be slightly pitted, but the basic structure, the form, the message, the design, all of it survives. Some scientists have estimated that Voyager could remain identifiable as an artificial object for billions of years, possibly longer than the Sun itself will exist as a stable star. Voyager may, in a very real sense, outlive its creators by a margin so large that the human imagination struggles to grasp it. So, what does Voyager actually see during this billion-year journey? In one sense, it sees nothing, because its eyes have long stopped working. But in another sense, it has front-row seats to the greatest show in the universe. It witnesses stars being born from collapsing clouds of gas, glowing pink and red and gold. It drifts past stars in their prime, blazing white and yellow. It passes the swollen red giants in their dying years, their atmospheres bloating outward. It watches supernovae explode in distant nebulae, briefly outshining entire galaxies. It threads through clouds of cosmic dust where the seeds of future planets are forming, and it bears silent witness as the architecture of the galaxy itself shifts, its spiral arms slowly bending and sweeping like the blades of a celestial mill. There is something deeply human and deeply moving about this. We built Voyager out of hope. We built it knowing we would never see what it saw. We attached a golden record to it, not because we believed aliens would find it. The chances of that are vanishingly small, but because the act of sending a message into the dark mattered to us. It was a statement. We were here. We loved. We dreamed. We made music. We laughed. And we sent that out into the universe, knowing it might travel for 1 billion years before being noticed by anything, if it ever is at all. In a way, Voyager has already accomplished something more profound than its mission designers ever intended. It has become a kind of mirror. When we look at Voyager, we don't just see a machine. We see ourselves. We see our courage, our curiosity, our refusal to accept the limits of our own lifetimes. We see the part of us that asks what is out there and is willing to spend decades and billions of dollars to find out. And 1 billion years from now, when our cities are dust, when our languages are forgotten, when even our planet may have changed beyond recognition, Voyager will still be out there, still drifting, still carrying its golden cargo, a monument not to power, not to conquest, but to wonder. So next time you look up at the night sky, take a moment to remember. Somewhere up there, in a direction roughly toward the constellation Ophiuchus, a tiny machine is sailing through the silence. It cannot hear us anymore. It cannot speak to us anymore. But it is still going, still carrying our songs, our greetings, our hopes. And it will keep going long after the last person who ever knew its name has been gone. That, more than anything, is what makes Voyager 1 immortal. Not its metal, not its electronics, but the human idea it carries. The idea that no matter how small we are, no matter how short our lives, we can still throw a piece of ourselves into the infinite and watch it sail away forever. If this journey through deep time moved you the way it moved me, please hit that like button right now. It really helps the channel reach more curious minds like yours. Subscribe and turn on the notification bell so you never miss our next deep dive into the wonders of the cosmos. And I want to hear from you in the comments. If you could send one message on the next Voyager, one final whisper into the dark for some distant civilization 1 billion years from now to discover, what would you say? Drop your message below. Let's see what humanity has to share with the stars. Until next time, keep looking up, because the universe is always listening, even when we cannot hear it back.